Hi everyone. Today we're going to study rational exponents. Let us first define rational exponents. These are exponents that are fractions, where the numerator is a power and the denominator is a root. A general term of rational exponent is this: x raised to a fraction m over n. As per our definition, this is equal to the nth root of x raised to m power. As an example, we have x raised to 2 over 3. And this is equal to the cube root of x squared. Take note, the number 2 here, the numerator, is the power of the x, and the denominator 3 is the index of the radical. There are two ways of writing an expression with rational exponent. The first one is this. When we have the x raised to m over n, it seems like we're going to split the m over n fraction into two factors. One is the m, or the numerator itself, multiplied by 1 over n. This fraction with numerator 1 and the n as the denominator. So as we see here, we have now the x with two exponents. One is the fraction 1 over n, and outside the grouping symbol is the exponent m. This is the second way. When we have the x raised to the m, or the numerator, and outside is the exponent 1 over n. Here is the review of the laws of exponents. We have this product property. We know that when we multiply exponent with the same base, we simply add exponents. We have quotient property. When we divide exponent with the same base, we subtract the exponents. We have this power property. When we have a raised to m, and outside there is another power n, this is equal to a raised to the product of the exponents mn. Next is the zero exponent property, that when we have any variable raised to 0, this is equal to 1, but there is a restriction that a should not be equal to 0. We have also the negative exponent property. Any variable raised to a negative exponent, we can rationalize this by putting 1 over a raised to an exponent positive n. Another restriction that a should not be equal to 0. Next is the product to a power. When we have this, the product ab raised to m, this is equal to a raised to m times b raised to m. And the last is the quotient to a power. We have a quotient a over b, and all raised to an exponent m. This is equal to a raised to m over b raised to m. There is a restriction that b should not be equal to 0. So let us have this example 1. Simplify 8 raised to 2 over 3. So I put the formulas on top here. And then I will copy this problem down here. Then using this first formula here, so you see now the 2 over 3 exponent is now split into two factors. One is the 1/3, the other is the whole number 2. The next step here is the number 8. We will show that it is equal to 2 cubed. So now it is 2 cubed raised to 1/3, and then all raised to power 2. The next step is we're going to multiply the exponent 3 with the 1/3. We will get this 3 over 3. And then we will simplify the 3 over 3 into 1. So any number with exponent 1, we can simply delete that exponent 1. So in here we have the 2 square. Then we can now simplify into 4. So it means that 8 raised to 2/3 is equal to 4. Now we're going to use the second formula to solve this problem. So the 8 raised to 2/3 is equal to 8 squared and all raised to 1/3. So I'm now using the second way. The next step is the 8 squared is equal to 64. Still the 1/3 is there. And then we're going to show the 64 is equal to 4 cubed. Still, the 1/3 power is outside the grouping symbol. And then we will simplify this 3 and the 1/3. It becomes 3 over 3 exponent. So 3 over 3 is equal to 1. Any number raised to exponent 1, we can delete that exponent. So simply 4 will come. So our final answer is 4. As we can see here, we have the same answer for both solutions. Let's have example 2. Let us simplify this negative 27 raised to 4 over 3. At first, I'm going to copy the problem here, and then I'm going to split the 4 over 3 exponent into 2, 1/3, and the whole number 4. Now we can see the negative 27 is raised to 1/3, and the whole expression is raised to 4. And then this negative 27 can be substituted by the value negative 3 all raised to 3. The next is this exponent 3 and the exponent 1/3 outside we can simplify. So we multiply this 3 and the 1/3, we will get this 3 over 3. And the exponent 3 over 3 can be simplified into 1. So then we will delete that exponent 1, becomes negative 3 alone, and then still the power 4 outside is there. Now it's time to simplify this negative 3 raised to 4. We will get this 81. So this negative 27 raised to 4 over 3 is equal to 81. Let's have example 3. We have the expression 2x raised to a negative exponent, negative 3 over 4, and then y raised to 1 over 4, and the whole expression is raised to exponent 4. So at first, what we'll do here, I will copy this problem down here. So this exponent 4 outside, I'm going to distribute to each variable inside. At first, it will be with the number 2, and then with the variable 4 raised to negative 3 over 4. So the exponent 4 is there outside. And then the y raised to 1/4, now with power 4. And then we will simplify further. The 2 raised to 4 becomes 16. And then from here we can cancel the denominator 4 and that exponent 4. So only negative 3 will come down here. And the y raised to 1/4 and the power 4 we can simplify. Cancel that denominator 4 and the power 4, only the numerator 1 will come down here. Then we will rationalize the negative exponent by simply putting the 1 over x raised to positive 3 or x cubed. Then on the next line we will simplify 16 multiplied to y, we'll get the 16y over the x cubed. So this is our final answer. Let's have example 4. This time we have a fraction here. In the numerator we have 8x raised to 1 over 2 all over the x raised to 2 over 3, and the expression is raised to 1/3. So I will copy the problem down here. Next, the 1/3 exponent I'm going to distribute to the 8 to this x raised to 1/2, also to the x raised to 2/3 in the denominator. So you can see here the 8 now with the power 1/3. The x with exponent 1/2 is now with the power 1/3. In the denominator, the x raised to 2/3 is also with the power 1/3. The constant 8, we can show that this is equal to 2 cubed. And then for the x, we're going to multiply the 1/2 and the 1/3 becomes 1/6. In the denominator, we will multiply the exponents. So 2 times 1 is 2 over 3 times 3 is 9. Next, for the coefficient 2, we can simplify the exponent 3 and the 1/3 becomes 3/3. We multiply them together. So for the x, we have now the division of exponent with the same base. So we can show that this is x raised to the difference of 1/6 minus the 2/9. On the next line, we will simplify the exponent of the base 2, 3/3 becomes exponent 1. Now for the x, we will use the crisscross method to simplify the difference of these two unlike fractions. If you are not familiar with the crisscross method, you can see the video of addition and subtraction of unlike fractions. So we will use crisscross method here. At first, we're going to multiply the 1 and the 9. The answer is 9. I will put the answer here, 9. And then the minus. Then I will multiply the 6 and the 2 becomes 12. The 12 is here. Then all over, the product of 6 and 9 is 54. On the next line, the 2 with exponent 1, we will delete the 1, no need to write. Now for the x, the 9 minus 12 becomes -3/54. Then we can put the exponent into lowest term. The -3/54 is the same with -1/18. We divide the numerator and denominator by the number 3. So for this answer here now, we will simply rationalize the negative exponent, putting it in the denominator. So the final answer is 2 all over the x raised to 1/18. Let's go now to solving equations with rational exponent. Let's have example 1. Solve 3x raised to 5/3 plus 96 equals 0. So for our solution, I will copy first the whole problem down here. So in solving equations with rational exponent, our goal here is to put that x alone in one side. All the other numbers we will put on the right side. So at first, this positive 96, we will shift it on the right side. So we simply subtract 96 from both sides. So from the left side, the 96 will be deleted. On the right side, the -96 will come. So this is now 3x raised to 5/3 equals -96. So in this line, the x is with coefficient 3. So we will divide this equation now by 3. On the left side, the 3 will be deleted. On the right side, we can see now the -96 divided by 3. And the answer here is -32. We want to make x to be alone in one side, meaning the exponent should be 1. We will do that by raising the equation to the reciprocal power of the rational exponent. As we see here, our rational exponent is 5/3. So the reciprocal of this is 3/5. That's why on this line, you will see that the left side is raised to 3/5. The right side is also raised to 3/5. So the next is, for the x, the exponent becomes 1 because the 5 over 3 is multiplied to its reciprocal, the answer will be 1. On the right side, the negative 32, we will express it as the negative 2 as raised to exponent 5. And then, we can cancel that exponent 5 with the denominator 5 of the power outside. So only the numerator 3 will come down here on the next line. And for the x with that exponent 1, we will delete it now. Only x can come down. So x is equal to negative 2 cube. Then we will simplify this negative 2 cube into negative 8, and that is our final answer. Let's have this example 2. The quantity x minus 3 is raised to 3 over 2 equals 27. First, let us copy that same problem. And then, in here, we want to delete that exponent 3 over 2. Or simply, we want the 3 over 2 exponent to be equal to 1. We will do that by raising the equation by the reciprocal power of the rational exponent. So the 3 over 2, the reciprocal is 2 over 3. That is why you see the equation now is raised to 2 over 3 on the left side, also 2 over 3 on the right side. Next is the 3 over 2 multiplied to its reciprocal will give 1. So the exponent now becomes 1. On the right side, the 27, we can show this to be 3 cubed. And again, the 2 over 3 is outside. On the next line, the x minus 3 with exponent 1, we can delete that exponent. It is understood to have exponent 1. On the right side, we can cancel the power 3 and the denominator 3. Only numerator will come down. So the 3 square becomes 9. And then, it is easy to put x alone on one side, the negative 3. We will simply shift it on the right side. So the negative 3 becomes positive 3. And then 9 plus 3 is equal to 12. So x is equal to 12. That is our final answer. Now, we're going to simplify expressions with rational exponents. Example 1. Simplify x raised to 1/2 times x raised to 5 over 6. We know that when we multiply exponents with the same base, we're going to add the exponents. So we have x raised to 1/2 plus 5 over 6. Then we simplify the exponent. 1/2 plus 5 over 6, we can use the methods. In here, we're going to use the crisscross method. So, 1 multiplied by 6, it will be 6, plus 2 times 5 is 10. All over, 2 times 6 is 12. In the numerator, 6 plus 10 is 16. All over 12, we simplify our fraction as 4 over 3. So our final answer, x raised to 4 over 3. Example 2. Simplify z raised to 9, and this expression is raised to 2 over 3. By our law of exponent, when there is an exponent that is raised to another exponent, we're going to multiply the two exponents. So we have z raised to 9 times 2 over 3. We can simplify by cancellation. The 9 we cancel with a 3. So the 9 becomes 3 and the 3 becomes 1. Then we multiply. 3 times 2 is 6. All over 1 is simply 6. So finally, z raised to 6. This is the final answer. Example 3. Simplify x raised to 1 over 3 all over x raised to 5 over 3. When we divide exponent with the same base, we subtract the exponents. So this will be x raised to 1 over 3 minus 5 over 3. Let us simplify the fractions in the exponent. We can see that the fractions have same denominator. So easily we can get the difference. And this will be 1 minus 5 is negative 4 all over the same denominator 3. So x raised to negative 4 over 3. Let us remove the negative sign. That means we will rationalize. And we will do like this. 1 all over x raised to positive 4 over 3. This is the final answer. Let us have more sample problems. Problem 1. Simplify w raised to 2 over 7 all over w raised to 9 over 7. In here, we are going to divide exponents with the same base. So we will apply our rule. We have now w raised to 2 over 7 minus 9 over 7. In the powers, we have this difference of two fractions with same denominator. So we have 2 minus 9 all over 7. In the numerator, we have negative 7 all over the denominator 7. So we can simplify our exponent into negative 1. So we have here w raised to negative 1. Then let us rationalize the negative exponent by doing 1 all over w raised to positive 1. When exponent is positive 1, we can simply delete it. Finally, the answer is 1 over w. Problem 2. Simplify 4p raised to 1/3 q raised to 1/2 all over raised to 3 over 2. We're going to distribute this power 3 over 2 to each of the terms inside the grouping symbol. So we have 4 raised to 3 over 2. The p that is raised to 1 over 3, again raised to 3 over 2. For the q that is raised to 1 over 2, now raised to 3 over 2. Let us simplify each of the terms. For the number 4, we're going to show that this is equal to 2 squared. For the p, we multiply the powers 1/3 times 3 over 2. So that is 1 times 3 is 3. 3 times 2 is 6. For the q, the powers we will multiply. 1 times 3 is 3. 2 times 2 is 4. And then let us simplify. For the number 2 squared that is raised to 3 over 2, we multiply this exponent 2 by 3 over 2. Or simply we can cancel this power 2 with the denominator 2. That means 2 cubed will come down. For the p, the power is 3 over 6 that we can simplify as 1 over 2. For the q that is raised to 3 over 4, we simply copy it down. Finally, we simplify 2 cubed to be 8. Then we copy the p raised to 1 over 2. And we copy q raised to 3 over 4. This is the final answer. Problem 3. Simplify 27b raised to 2 over 3, c raised to negative 5 over 2, all over b raised to negative 7 over 3, c raised to 1 over 2. All of this raised to the power 1 over 3. We're going to group together the number, the variable b, and the c variable respectively. So we have like this. 27, the number is separated, times the b raised to 2 over 3, all over b raised to negative 7 over 3, times the group for the variable c. C that is raised to negative 5 over 2, all over c raised to 1 over 2, all over the power 1 over 3. Let us simplify the fractions. For the 27, there is no change. For the b, we apply the rule. So we have b raised to 2 over 3 minus the negative 7 over 3 times the variable c raised to the negative 5 over 2 minus this 1 over 2 all over the power 1 over 3. Let us now simplify the fractions. We copy the 27, the 2 over 3 here minus the negative 7 over 3. Negative and negative becomes plus, so we have 2 plus 7 becomes 9 all over 3. And then the c, the negative 5 over 2 minus 1 over 2. Same denominator, so we can have to combine the numerators. Negative 5 minus 1 is negative 6 all over 2. Again, the power 1 over 3 is copied. We simplify further. The fractions, the 9 over 3 becomes 3, and this negative 6 over 2 becomes negative 3. We copy the 27 along with this power 1 over 3. From here, we distribute this 1 over 3 power to each of the terms inside the grouping symbol. So we have 27 raised to 1 over 3. This b cube now raised to 1 over 3. And this c raised to negative 3 now again raised to 1 over 3. Let us now simplify. For the variable b with power 3, we multiply by this power 1/3. Or simply we can cancel 3 by this denominator 3. For the variable c, the negative 3 power multiplied to the power 1 over 3. Or we can cancel this negative 3 by this 3. So it becomes negative 1 in here. For the b, we have a positive 1 power, no need to write. For the number 27, we can show that this is 3 cubed. Then, we multiply this power 3 by the power outside, that is 1/3. Or simply we can cancel this power 3 by the denominator 3. That means only the number 3 comes down in simple term. Then we copy the b along with the c with the negative 1 power. We rationalize this negative power by putting this in the denominator. So we have 3b all over c with a positive 1 power. So we don't need to write it. Finally, our answer is 3b over c. Problem 4. Solve 6x plus 1. This group is raised to 1 over 2 power. Minus 3 equals 4. We're going to do 2 steps. The step 1 is we isolate the rational exponent. In this equation, the rational exponent is this 1/2 with a base 6x plus 1. That means we want this alone in this side. This negative 3 we transpose to the right. So the minus sign becomes plus. That means on the right we have now 4 plus 3. And that would be 7. Then we have the step 2. We're going to raise this equation into a power reciprocal to that rational exponent. The rational exponent here is 1/2, so the reciprocal is 2. That means we're going to raise this equation into power 2. this power 2 will come to the left side and to the right side, just like this. Let us now simplify the left side. The 1/2 power we multiply by the power 2, or simply we cancel this 2 by the denominator 2. That means this 6x plus 1 simply comes down, equals, we simplify the right side. 7 squared is 49. Then we solve for x. This plus 1 we transpose to the right side. So we have 49. The plus becomes minus 1. 49 minus 1 is 48. And then we divide this equation by the coefficient of x, which is 6. Or we can see that x is equal to 48 over 6. When we divide, the quotient is 8. So this is the value of x. Problem 5. Solve 12x minus 5. This group is raised to the power 1 over 3. Then plus 8 equals 3. The step 1 is we isolate the rational exponent. This is our rational exponent. This plus 8 we transpose to the right. It changes the sign. So 3 minus 8. And the difference is negative 5. Then step 2. We raise the equation into a power reciprocal to that rational exponent. Our rational exponent here is 1 over 3. That means the reciprocal is 3. Then we raise this equation into this power 3. By doing that, this exponent will come to the left side and to the right side of the equation, just like this. Now let us simplify the left side. This 1 over 3 power we multiply to this 3, or simply we cancel this 3 by the denominator. That means we simplify by putting this 12x minus 5 down, equals, we simplify the right side. The cube of negative 5 is negative 125. Let us now solve for x. This negative 5 we transpose to the right, it becomes plus 5. So negative 125 plus 5 is negative 120. We divide the equation by the coefficient of x, which is 12. Or we can show that x is equal to negative 120 all over 12. Finally, x equals negative 10.